Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Southern California Gas Company, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Susie. And you can call us with your math questions today at 636-4357. If you're in San Luis Obispo or other areas, you can call toll-free at 1-866-636-6284. You can also email us at dothemath@kern.org. You can also watch online at dothemathonline.net. And we are also on social media, Facebook, Instagram, Twitter, and YouTube.
All right, quick programming note, because today is the 13th and tomorrow is Pi Day, 3/14.
Right.
Today are the final 2 days of live broadcast for Do the Math for this season. So if you do have questions, you need to get them in today or tomorrow, the final 2 days of live broadcasting for this season. In a little while, we'll be going out to Actis Junior High, visit April and some students out there doing some work. We have a very special guest in studio. But before we get to any of that, let's first take a look at today's Math in the News. And this literally ripped right off the front page of Saturday's newspaper. So here it is, the front page of the Bakersfield Californian on Saturday. Working the problem. Students put their math skills to the test during annual competition. These are students and they're from Kern Middle School, and this is part of the 300 students that took place in a math competition with the Bakersfield City School District, and it was the 32nd annual Math Bowl. And are you familiar with this?
Oh yeah, I've been.
Okay. And one of the Do the Math tutors, Hilda, works with Do the Math, was kind of one of the people putting this on and helped coordinate and things like that, and says this is something that motivates them, and one of the other quotes is, we're trying to make it fun because math should be fun. And indeed, it shouldn't be, you know, like, oh, I don't want to do my math today or something like that, because that way students can see how it relates to everyday things that go on in the world every day. So I figured let's go ahead and take a look at some of the problems down here. And it was, are you smarter than a 6th grader? All right, so let's go ahead and we'll just take a look at some of these right here. If the pattern below continues, what letter would appear in the 400th position? So it says math is the greatest, math is the, and then it just keeps on going. Another one is, what's my number? And then you've got some clues. The number can be divided into 240 evenly, divisible by 12, greater than 25, and less than 50. So with all of those clues, you can come down with what the final number is. And then you've got another one where you've got an item, and then you've got it on sale with a discount taken off and things like that. But this is what drew me to finally use this one for today, because here are the answers, and right there it says, do the math.
Of course.
So it's like, oh, do the math, and then that way you can figure it out. That's right, hooray indeed. So you can see some of the answers right there, and the one with the, can you figure out the number? Well, you can see that with all of the different clues, it comes out to be 48, and then they have a substantial explanation of the final one, where you're doing the percent, taking it off, and things like that. And that is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available until 5:30 most Tuesdays and Wednesdays. However, as I just mentioned, today and tomorrow, the final 2 days of live broadcasting for Do the Math this season. In studio, we have Audrey, and how are you today?
Good.
Why don't you let everybody know where you go to school and what grade you're in?
I go to Bill L. Williams, and I am in 6th grade.
Now, how long have you been at Bill L. Williams?
Since I was in kindergarten.
So you've been there 7 years now. So you are a pioneer at heart through and through, correct?
Yes.
All right. Now, there are a lot of times I ask, all right, what's the best thing about Williams? What are you going to miss? Things like that. So you're getting ready for junior high next year. Have you gone to your orientation yet?
No.
So you're going to be doing that pretty soon, right?
Yeah.
Do you have any idea when that is?
It's on Thursday.
Oh, this coming Thursday?
Yeah.
Oh, so it's right around the corner. So what's one thing you anticipate, or one thing you're looking forward to, or one thing you think you're going to find out about junior high when you go to the orientation?
I want to know what like all this each classrooms are, and I want to see like where the orchestra room is and meet the like orchestra teacher.
Okay, so you're in orchestra now, or is that something you're going to start?
I'm in orchestra.
You're in now? What do you play?
The violin.
Yeah? You pretty good? Yeah, there you go. Why not? Yeah, you're pretty good. You're pretty good, right? Well, you know what? We've got a couple of minutes. Why don't you head on over to the board, and we're going to take a look at some of the things that you're working on in class right now, okay? All right, head on over there with Susie. And this is a problem that I am quite confident you'll be able to solve, all right? So let's go with, let's turn the page so that we get some other distributed property in here. All right, 5. So go ahead and start the problem all the way over on the left. There you go. So 5, open parentheses. Yep. 1 plus 5n, close parentheses, minus 3n equals 115. Or 115, yeah. So you can just erase that 0. 115. And if you would be so kind as to solve for n and explain to Susie what you're doing, and if you get stuck somewhere, Susie's right there.
What are you going to do first?
5, 5, 1.
I agree.
And 5 times 5.
You're going good.
Minus
I think you're bringing down the 3n, the negative 3n.
equals 115.
How do we move it down again to give her some more room?
Oh, you can just slide it on the side. You see the bar?
Oh, yeah. Oh,
Whoop. There you go.
there we go. Okay. Let me guess. Are you going to combine like terms?
Yeah.
Oh, okay. Read your mind.
The 25n and the 3n.
Right. So she still has the 5. Mm-hmm.
22n
Mm-hmm. I agree.
equals 115.
Okay, let's give you some more room.
And then you subtract the 5 from both sides.
I would agree.
Are they ready?
Oh.
Are they ready?
That's okay. We know it's a 5.
Minus
Yep.
I don't need the positive sign, do I?
No, it's okay. It wouldn't hurt. Okay.
22n equals 110.
Mm-hmm. We're almost out of room. We might have to go over to the side.
There you go. Yeah, you can just go over to the side if you need to.
So what are you going to do next? I can tell that you know.
Divide 22 into 110.
Yep.
Oh.
Sometimes you can kind of estimate. 22 is close to 20, and 110 is kind of close to 100. So you can get a good start by thinking how many 20s go into 100.
5.
Okay, so try that. If it's not 5, it'd probably be 4 or 6, but 5 sounds good to me. You can also check it this way. You can just do 5 times 22 and see what you get. Because that's what you were going to go around and do anyways, right?
Yeah.
It works, doesn't it?
Yeah.
Okay, so if we divide both sides by 22, okay, so you already did that.
Yeah.
Do you know why we only have n left here?
Because n is a variable.
Right, and then what's 22 over 22?
Just n.
It's just 1, and 1 times n is n. Okay, very good. Think she knows what she's doing.
There you go. N equals 5. Nicely done on that first one, Audrey. 636-4357 is the phone number. We do have phone tutors available until 5:30. Right now, we're going to go out and about, visit with April at Actis Junior High.
Hello. We're here at Actis Junior High, home of the Americans, and I am here with Mina. Mina, what grade are you in?
I'm in 7th grade.
7th grade. And what do you like here about Actis?
I like the PE sports and games that they play.
Very nice. And what's your favorite subject here at Actis?
Math.
We are in the right place here. Okay, so we have a problem today. Do you know what we're working with?
Inequalities.
So today we're going to work with inequalities. Here we have, go ahead and pick up this pen. 4m is, what does that say? Do you know?
Greater than or less than.
Greater than or equal to?
Negative 4.
Negative 4. So we're working out 4m is greater than or equal to negative 4. And how many solutions are we going to have here?
Infinite answer.
Okay, so we're going to have an infinite amount of solutions. If I'm looking at this problem, what am I looking for?
You're trying to figure out the value of n.
The values, because there's infinite, right? There's more than one. So we're trying to find all the values of n. So I have 4 times m is greater than or equal to negative 4. So what should I do in order to find that value of m?
You're supposed to divide 4 by negative 4.
So let's see you do that. So why are we dividing 4 by negative 4?
Since
Or
it's-
positive 4, right?
Yes, positive 4.
Okay, so why are we dividing 4 by 4?
Because in order to get the answer, then you need to do, what is it, inverse operations?
So inverse, so this is 4 times m, so we need the inverse operation, so we're going to divide by 4 on both sides of the inequality. And what do we know about m?
M can be any answer. It can be an infinite amount of answers that we don't know yet.
Okay, so m is going to be greater than negative 4 divided by positive 4 is negative 1. Perfect. Okay, so since I have an infinite number of answers and it's not just not one single answer, how can we show that? What's the best way to show that?
With a graph.
Okay, so we're going to graph on a number line. We're going to start with 0, very nice. And then we're going to put, is it okay if we don't put other numbers on there? Okay, that's fine. Let's cap that, because when we show the answers, let's show in a different color so we can be visible here. So where are we going to start on our number line?
We're
At,
going to start at negative 1.
so do I put an open circle or a closed circle, and why would I do whatever we're going to choose?
You put a closed circle to show that it can be either negative 1 or anything greater than negative 1.
Because here, where it says equal to, it includes negative 1, so we're going to close that circle. And if m is greater than negative 1, how do we decide what numbers those are?
Then you would put it that way, showing that it can be anything.
So that means that 0 is greater than negative 1?
Yes.
And then 1 would be greater than negative 1? And then so like 25 would be greater than negative 1?
Mm-hmm.
Perfect. You want to do another one over here?
Sure.
Okay, so over here, let's write, you can write it with blue. X minus 7 equals, I'm sorry, we're not equaling. We're going to go less than is less than 12. Okay, so how would I do this one?
Then you would.
Because are we multiplying now?
No.
No, what are we doing?
You would add 7 to 12.
And I'm adding 7 because it is the
Inverse.
inverse of the other one, so we're going to add 7. Are we going to add 7 anywhere else?
Yeah. 2 7 also.
Okay, okay, we have to use inverse operation to cancel.
That would just make x by itself.
Okay, x is less than 19. Okay, so how many values are we talking about here? Infinite amount of values. We're going to show that on our number line. Okay, so what kind of circle are we going to put on 19 this time?
We're going to
Choose
put-
this pen.
We're going to do an open circle.
An open circle. So does that mean 19 is included when we open the circle?
No.
Okay, go ahead. So we'll open circle, which does not include 19. And what numbers on the number line are less than 19?
Anything to the left.
Anything to the left. So every number to the left. So 18 is less than 19, and then 0 would be less than 19. And here's the top to that pin. Perfect job. Thank you very much. Back to you in the studio.
All right, thanks for that, April. Great work out there at Actis Junior High. Hey, we do have phone tutors available until 5:30. We've got a very hard worker in studio with us right now, Audrey, so let's put her back to work. All right, young lady, back to the board with you. Here comes your next problem.
Let me move this back up so we can have something to move down. Okay.
24 minus A is equal to 2, open parentheses, 2 plus 4A, close parentheses, plus 2. All right, have at it.
So it looks like you're bringing down the 24 minus A.
And then equals, and then 2 times 2
That's right. 2 times 2 is 4.
plus 8. Oh, that does not look like
I
an
can
8.
see that it's an 8. 2 times 4A is
8.
8.
A,
Good.
and then plus 2.
Okay.
Then 24 minus A
Bring down the 24 minus A again.
equals, and then combine like terms, so it'd be 6. Oh, it's
Okay.
6 plus 8A.
Good. Have you done it with variables on both sides? Well, you know how you can take off numbers from both sides?
Yeah.
You can also take variables off both sides. So I could get rid of subtracting A by adding A, and then I would have to add A to that side too. So why don't you just try that and see what happens? Okay,
So then
go ahead.
just be 24 equals 6 plus,
So 8 A's plus another A. If you have 8 alligators plus an alligator,
is 9.
9 alligators. Yeah, 9 A's. Okay, let me move it down. You did really good with that. So that's a new thing? Great. Okay,
And then
so you're trying to isolate that 9A.
so then it's minus 6.
Great.
And minus 6.
Mm-hmm.
Be 18 equals
It's okay, the positive doesn't hurt.
A.
That's actually a good habit that you have of not leaving off that sign in case it's negative, right? Okay, so now what do you do?
Divide 9 into 18,
Right.
which is 2.
Uh-huh.
So A equals 2.
That's correct. Let me show you something. Not everybody does it this way, but some people divide it like this. I need to divide both sides by 9 in order to get rid of that 9. Now it turns into 1. 1 times A is A, and 18 divided by 9 is 2, just like you said.
All right, so you ladies came up with A is equal to 2, and that's what you said. How do you know that it's 2? Is there
You
a
know
way
what
that
to
you can
do?
do that to make sure that you're positive with that answer and it's correct?
Okay, so let's go back up here, okay? Because this is how we find out if we made a mistake. So have you done that before? So I have 24 minus, and I'm going to change the a to a 2, okay?
Okay.
Equals 2 times 2 plus 4 times 2. What's 4 times 2?
8.
Okay, and then plus 2. Okay, so what's I'm going to go backwards. What's 24 minus 2?
22.
Okay, 22. Okay, and then I have 2 times, what's 2 plus 8?
10.
10. Does it look like it turned out to be true? Yes, because this here is 20. Okay, so
Plus
20 plus 2
2
is
20.
22. So when you put the number back in, you want it all to be true. Okay?
All right, nicely done. Well, clear the board, ladies. I've got one more for you, but this time we're going to throw some negatives in there for you.
Whoa.
All right, so here we go. -6 minus x is equal to -3, open parentheses, 4 plus x. Close parentheses and solve for x.
Okay.
Okay.
So you certainly know how to get started on this one, don't you? Okay. So you're going to bring down that.
Yeah.
That's right.
-6. And then -12 and -3x, because 3
Good.
times x is 3x.
Okay, so now we have that same problem again where we have x's on both sides. Okay, so you can get rid of -x by adding x to both sides, or you could get rid of -3x by adding 3x to both sides. Which one do you want to do?
Add 3x.
Okay,
to
that's a
both
good
sides.
choice. Okay, because you will have less negatives to work with. Okay, so add 3x to both sides.
So this cancels out.
That's right.
And then, would that be just 3?
Well, you bring down the -6 first. Okay, and that is a common thing that happens. People think 3x minus x is 3 because you just take off the x. But this actually means like 3 x's and then take away an x. So it's like 3 x-rays minus an x-ray.
So it's 2x.
2 x-rays, yeah, 2x. And it's positive now. Excellent.
So then you add 6
Very good.
to both sides. 2x equals -6.
Good.
Then
So-
it'd be x is equal to 3.
Almost. Just think about the sign. You have -6 divided by 2.
So it's -3.
Right, x equals -3. So you divided both sides by 2. That gave us x. And then -6 divided by 2 is -3.
All right, nicely done. Been doing some great work. And we need to make sure that when we're doing math, we are fed properly. We don't want to do math problems on empty stomachs. So
Right.
what we're going to do is send you to our friends over at Chick-fil-A and just eat a meal over there. So congratulations on that. So I've got one more problem for you before we let you take a break for a minute. You ready?
Okay.
All right, so this is going to be a ratio problem. So you can just write down some, so Susie, maybe just write down any information you guys think
Okay.
you're going to need. All right? In a certain room, there are 28 women and 21 men.
Okay.
What is the ratio of men to women? That's the first one. So the
Okay.
ratio of men to women. And the second part is, what is the ratio of women to the total number of people in the room.
Tricky. Okay. Of women to the
Of
total?
women to the total number.
Okay, so I used M for men, women, and total, okay?
Yeah.
Well, you want to know what to do? Can you reach over here and do it? I think you could.
For men to women,
Mhm.
it's 21 to 28.
Good.
But what do we want to do with that?
Yeah, do you have to simplify it when you're in your class?
No.
Well, when you get to my class, you will, so. We'll get ready for 7th and 8th grade here, okay?
Okay.
So if you write it as a fraction, well, I didn't write that very well. Would you know how to simplify that?
Divide them both by 3.
Well, 21 is divisible by 3, but not 28. I think I know what you were getting the 3 from,
7.
though. Yeah. And now what do you have? Almost. I think that, I don't know if your 4 turned into a 9 or what. But there, now it looks like a 4. Okay, so that's the simplified ratio. Okay? Now how about women to the total? How could you get the total?
You add women and men.
Very good. Okay, so what's the total then?
49.
Okay, so 49 is the total. Okay, so now you want to do women to the total. Should I give you some more room? Oh, we might have to go the other way. Okay, we're going to do women to the total up here.
Okay. 8 to 49.
Now, we could make it a fraction, or you could think, which number, can you think of a number that goes into 28 and 49? It might be the same one you used in the last problem.
7.
Right, so what's 28 divided by 7?
4.
So like if I did it like this, oh, that's interesting how it changed color on me, huh? What would I get? You can tell me, because I'm taller than you, okay? Here, what's 28 divided by 7?
4.
And what's 49 divided by 7?
7.
Okay, so you can write it as a fraction, or you can write it like this, or you can write it like this. Did you learn all those ways to write it?
Yeah.
Good.
All right, nicely done with the ratios right there. 636-4357 is the phone number. We do have phone tutors available until 5:30. Programming note, we'll also keep reminding you of this. Today and tomorrow, the final 2 days of live broadcasting for Do the Math this season. We'll be back with more right after this. Today we're at Sunset Middle School, home of the Rockets, and today we're here to
Do the math! Yay!
Well, this afternoon we're at Sunset Middle School, and I've got 8th grade student Haley with me. How are you?
Good.
You ready?
Yeah.
All right, let's go. We're going to work on calculating the percent of a number. What can you tell me right now about percent? Is there anything you know about percent? What can you tell me? If you take a test, what's the highest percent you can get?
100.
So you want to get 100, right?
Yeah.
So percent is something out of 100, because you always get 100?
Yeah.
You always get 100 on every test?
Oh, no.
Oh, okay. I was going to say, I'm start studying the way you study, because I know I've never gotten 100 out of everything I've done. So a percent is some part out of 100. So the 100 is the whole thing, okay? So we want to find 32% of 29. So how would you go about solving this problem?
Dividing.
You want to divide? What else could you do? Do you know what the word of means?
Yeah.
What? In math, it means a certain thing. Okay, so it means we're going to multiply something. Okay, now we could go 32% written like that, but it's going to be more difficult. So how could we rewrite that to make it easier to multiply? Because if we have a percent, let's say you got a 90% on a test. That would be the same as 9 out of 10 or 90 out of 100, correct?
Yeah.
But we really don't want to deal with fractions. If we can, let's do with decimals, all right? So how would we rewrite this as a decimal? Do you know how to do that? If we go 0.9. You've seen that before?
Yeah.
Right, okay. And then 90 hundredths, right, would be the same thing, okay? But we just don't need that 0 at the end because we just have 0.9, all right? So if I want 32%, how would I rewrite that as a decimal?
0.32.
Right, so why don't you go ahead and put 0.32 right there. So 0.32 is 32 out of 100, which is what that means, 32 out of 100, okay? So it's going to be 0.32 times what?
100.
Well, we're going to go times the other number we want, right? So go ahead and rewrite that number. So we have 0.32 times 29, all right? So we'll get rid of this so we have more room to work here. So now, when you multiply, if you multiply with a decimal, we don't even have to worry about the decimal right now until we get to the answer, all right? So go ahead and multiply those for me and show me how you're going to multiply that out. All right, now there are some students watching this that aren't really sure on how to multiply yet, so explain to me what you're doing as you're doing it.
So first I will multiply 2 times 9, then I'll multiply 9 times 3.
Okay, so we know that 2 times 9 is 18, but why do you only write an 8?
Because we can't put both numbers right here, so I'll put the 1 over the 3.
Okay, so you're going to carry that 10. Okay, so now what do you want to do?
Multiply 9 times 3.
And what's that?
27.
Mm-hmm. So you said 9 times 3 is 27.
And
Well, what are you doing erasing already?
I had to add a 1.
You had to add the 1. Why do you have to add that 1?
Because I can't leave the 1 right there.
You can't leave it by itself, right? You put it up there for a reason, so we're going to use it, right? It's another 10. Okay, so now what does it become?
28.
All right. Now what do we do?
Then we multiply 2 times 2. Well, first we would have to imagine that there's a 0 right here.
Well, you can put a 0. We don't have to imagine it, right?
Oh, 'cause-
So a placeholder, right? Sometimes kids put an X or different things in there, but a 0 will work as well. All right, so now what?
we'll multiply 2 times 2, which is
Okay.
4.
Good.
And then 3 times 2, which is 6.
Now, before you keep going, you've done everything perfect so far. So you went 2 times 3 is 6. Do we need to use that 1 again?
No,
Why not?
because we already used it.
Because it was part of the 18, right?
Yeah.
Okay. I just want to make sure because some kids will go, well, you used it once, why not use it again? But that's why. All right.
So then we just add it.
All right.
And we just add a decimal right there.
Why do we put the decimal? Make it a little darker there. Why do we put the decimal right there?
Because we had a decimal right there, but since we didn't use it right here, we just had to put it right there.
But why not right there?
Because we only moved it. We only had to move it once.
If we have it here, how many numbers are after the decimal point?
2.
2, right? So in this number, right, you had 9, 2, 8. If there is no decimal in a number, where is it? Just think of 928. Can I write 928 like this?
Yeah.
I can still do that, right? So if there's no decimal present in a number, it just goes at the end, right? So 928 is what you came up with. And there were 2 numbers after the decimal point here. So in order to make it 32, you had to move it 2 places, right? Okay? So what we're going to do is we're going to move this 2 places, right? 1, 2. So we get 9.28, which is the same thing you got, isn't it?
Yeah.
Okay. How would you read that number instead of saying 9.28? Can you think of another way to say that? Because if I have this, how would I say that?
2 out of 10.
2 out of 10, or I could say 2/10, right? How would I say this?
2 out of 100.
2 out of 100, or
2 hundredths.
2/100ths, right? Because there's 2 places. So this is the tenths, this is the hundredths. So now how could we say this? We could say 9
Out of
and
28 hundredths.
there you go, because of the 2 places, right?
Yeah.
So you have the whole number, and then the decimal point is always and. So it's 9 and 28 hundredths. But, so what is 32% of 29? What is our answer?
9 and 2/8 hundredths.
9 and?
28 hundredths.
There you go, 9 and 28 hundredths. Haley, good work. And a big thanks to all of the staff and students out there. Always great to go do a little math in your class at your school. And if you'd like to do the math to visit your school, all you have to do is give us a call. The phone numbers are periodically at the bottom of your screen. Just say, hey, next year when you guys are going out, come on out to our school, check it out, and we'll do some math with you guys. We're going to make Audrey do some more work, but we're going to let her rest for a moment. Right now, we're going to go back out to Actis and visit with April.
We're here at Actis in their ACES program after school, and now I'm here with Anna. Anna, what grade are you in?
7th grade.
7th grade. And this is the ACES after school program, right? Yes. What do you like about ACES?
I like to cook.
You like to, what's your favorite thing that you've made here at
No
ACES?
baked Oreo.
What's it called?
No baked Oreo.
That sounds delicious. What'd you guys use for the filling?
Vanilla.
Vanilla, and then what'd you use for chocolate?
We just use the Oreo.
The Oreo. Was it yummy? Yes. All right. So today we're going to do a math problem. Let's go with, we're going to solve a 2-step equation, right?
Yes.
Okay, so let's go with 5x minus 9 equals 21. Do you know why this is called a 2-step equation?
No.
It's okay. We'll figure it out in the end. Okay. So, what's a good thing that we can do here? When we have equations, we have to balance our equations. So I'm going to put a balancing line here. Okay? And this line is going to tell me if I complete an operation on the left side of the equal sign, I have to complete the same operation on the right side of the equal sign, right?
Yes.
Okay, so what's the goal here? What are we trying to do? In 5x minus 9 equals 21, what do we need to find?
We need to figure out what the x represents.
What the x represents, okay? So we want to isolate that x, and in order to do that, what should we do first? It says 5x minus 9, so what should we do?
Make it a positive 9.
So we're going to add 9 with a plus. And to keep my equation balanced, so if I have a plus 9 on the left side of the equal sign, what do I have to write on the right side of the equal sign?
9.
Plus 9. And then draw a line right underneath that, okay? So what happens with negative 9 plus 9?
Become a 0.
Yes, so let's just cancel that out. And on the left side over here, what do we have left? Like if that's 0, what do we have left there?
The 5x.
Let's go ahead and bring that down under the green line. And then our equal sign again. On the right side, 21 plus 9 is
30.
30. So I have 5x equals 30. So 5x, what kind of math is going on there? Are we adding, subtracting, multiplying, or dividing? 5 and x.
Dividing.
But with them next to each other, this is multiplication. So what's the opposite of multiplication?
Division.
Division. So I'm going to divide by
5.
5. And on the left side, I have to do on the, keep my equation balanced. On the right side, I'm going to divide by 5. And what's 5 divided by 5?
6. Wait, 5 divided by 5?
Yes.
1.
1. Okay, so then that's going to be a 1, and we don't necessarily have to write that 1. So let's put an x over here. And 30 divided by 5.
6.
6. And so now we found the value of x, right?
Yes.
All right, so count with me. Start with 1. Count.
9.
1, 2. How many steps did you take?
2.
That's why it's a two-step equation, because there's 2 steps. Let's do another one. So we've got 2x plus 3 equals 9. So how would I solve this equation, this two-step equation? So let's draw a line, there we go, for our balancer.
Wait, this is to be a -3?
I'm going to subtract 3 because it's the inverse operation, right? And is my equation balanced or imbalanced right now?
Unbalanced?
In balance, how do I balance it? If I have subtracting 3 on the left side, where else do I need to subtract 3? Okay, let me see it. So on the right side as well, we have to subtract 3 on both sides of the equal sign. Let's go ahead and draw a line. And we're subtracting that 3 because we need to isolate x and cancel out anything that's on the same side of the equal sign. So that 3 minus 3 is going to...
0.
Okay, so cancel it out. What do we have left?
2x.
2x. And 2x is going to equal... What's 9 minus 3?
6.
6. Go ahead and write 6. That's step 1 of our two-step equation. Okay? So now I have 2 times x equals 6. What's the opposite operation or the inverse operation here?
Division.
Division. I'm going to divide by
2.
2 on one side of the equal sign?
Both sides.
Both sides of the equal sign. And 2 divided by 2 is?
3. Wait, 2.
2 divided by 2, this side. 1. Okay. So that gives me 1x. So all I have is an x over there. Mission accomplished. And x is going to equal 6 divided by 2?
Will be 3.
3. And that's the value of x. Great job. Back to you in the studio.
All right, thanks for that, April, and thanks to the students out at Actis Junior High. We also had Audrey working on that while she was singing back here in the studio. Now it's time for you to get back to your own work, not doing the other kids' work. So back to the board with you, young lady. Here we go. So 3 over 12. So we're going to multiply fractions. 3/12. So 3 over 12 times 4 over 21. And there are a variety of ways to solve this. So I'd like you to show me 2 ways you can do this problem.
Oh, well, I won't move it yet.
You can do the cross canceling and you divide.
Okay.
So it'd be 3 divided by 21 is 7.
Or you can think how many?
And
3
3.
goes into 21 7 times. Okay.
And then 3, 23.
Here, I'll write it up here again. Just go ahead and do it how you want to do it, and then we'll do it another way. Okay?
Okay.
So you can go ahead and cross out. You can cross cancel. Do you remember how to write it? Okay. Well, there's different ways, but 3 goes into 3 once,
and then
into 21.
7,
I don't know what I'm doing. 7 times. Good.
and then working on 12.
Yeah. Go ahead. Now you know what to do.
Okay.
Okay, I'll help you. 4 goes into 4 once, and 4 goes into 12.
3 times.
Good.
So it equals
Now do you know what to do? Multiply the numerators
1 times 1,
and multiply the denominators.
21.
Very good.
So
That
now what
is-
about the other way? Let's say she didn't know about cross-canceling or simplifying first. What's another way you could solve that problem?
So if you don't know anything about cross-canceling, you go ahead and multiply the numerators. Good. And then if we multiply the denominators, well, here, let's put it here where you can do it. Okay, better, easier.
And then placeholder.
Well, you're pretty fast.
252.
So write that there. Okay, so I'm going to erase this so you have room now, okay? So whenever you have something like that, you need to simplify. Do you know how to simplify it?
Divide.
Yep. Can you think of a number that goes into 12 and 252? Well, they're both even.
So 2.
You could try that, okay? Okay, and then what would you get?
6 over.
You could do partial quotients. 252 divided by 2.
Would be
200 divided by 2 is
1.
okay. And then 52 divided by 2. What's 50 divided by 2?
Oh, 25.
All right, so 52 divided by 2 would be one more.
26.
Right, 126. Oh man, we still got a big problem here. You know what? I'm going to just try 6. How could you find out if 126 is divisible by 6?
Well, you can do 6 divided, or 12 divided by 6.
Okay.
And then then do 12 divided by
Okay, so 12 divided by 6 is 2.
2.
And 6 divided by 6 is
1.
Good. Did we get the same answer? We sure did. And in fact, you could have divided by 12 over 12 here to make it faster, but it's kind of hard to see that 252 is divisible by 12.
Right. Nicely done, though. She got it the simpler way the first time around.
Yeah.
So I was expecting you to kind of just multiply straight across the first way. But you did both ways and you got it correct. So, hot shot, let's try another one. You ready? Instead of multiplying, now we're going to divide. So 5 over 6.
Let me move this up so I have room to, okay.
Divided by 2 1/6.
Okay. Do you know what the first step is?
No.
Well, when I teach this to my students, I tell them they have to first change mixed and whole to improper. Do you remember? So you have heard that step, huh? Okay, so 5/6 is okay, right?
Mm-hmm.
Do you know how to change 2 1/6 to a,
6 times 2 plus 1.
right? So that's
13 over 6.
6. Okay. Now, it is possible to do division this way, but you have probably been taught
To flip it.
yes, and that's called multiplying by the reciprocal. So let's write the new problem. Well, here, we'll bring it down. Okay, so what's the new problem?
6 over 5 divided by 13 over 6.
This one stays the same.
Oh.
Okay, do you remember that? And this one changes to multiplication, and then you change it to the reciprocal.
So 6 over 13.
Right, that's correct. Okay, and since you did so well with that other multiplication problem, I bet that you know what to do here. Do you see?
Oh.
Yep, yep, you saw it.
So this is 1,
Mm-hmm,
and this also turns into 1.
mm-hmm.
So then 5 over 13.
Good. So I'll tell you a secret. It doesn't happen very often, but see how these were the same there? 5 divided by 13 is 5/13. But that doesn't happen hardly ever. So it's not something we teach very often.
All right, well, you know what? You ladies are on a roll. We're going to give you one more problem. I'm going to modify this one off the paper a little bit now.
Okay.
All right, 11 5/7. 11 5/7 plus 8 6/7.
Okay. So how do you like to do these? Some people like to stack it, and some people do like to change them into improper fractions, which is a good thing to do if you have negatives or borrowing, regrouping, but you actually don't need to do it here. Do you know how to do it stacked? Where they're on top of each other? Okay, so let me, okay, go ahead. You do it the way you want to do it.
19.
Mm-hmm.
And then that changes into a mixed number. 13 over 7.
Well, that would be correct if you did 5 plus 8. But you actually have 5 plus 6, yeah. Okay, so are you done?
No.
What do you think you could do?
You have to change that to a fraction.
That's right. You know how to do it?
You divide.
Right, you can divide. I'm so glad that you know how to put the numerator inside. Okay, so how many 7s go into 11?
1.
1. And 1 time, good.
And
And there's 4 parts left over. And what kind of parts are they?
remainder.
They're 7s, aren't they? So 1 and 4 sevenths. Okay, so what do you do with this?
You add it to this.
Very good.
So it's 20 and 4 sevenths.
Excellent.
There you go. Nicely done. Could not get one by you today, Audrey, right there. Hey, you know what? Come on over here again real quick, Audrey, because you said that you are looking forward to junior high. And what is your favorite subject right now?
Math.
You like doing math, right?
Yes.
I mean, you know, you're not only saying that because you're on Do the Math today, are you?
No.
You really like doing math? Well, you're going to do a lot of it next year, and you're going to do all of the things we did today and a whole lot more. All right? You know what? Actually, we're going to go one more time out to Actis and see what they're working on. So we'll go out to Actis with April one more time.
Hello, we're back here at the home of the Americans, and this time I have Lindsay with me. What grade are you in, Lindsay?
8th grade.
8th grade. And what's your favorite subject here at Actis?
English.
English, not math? It's okay, we'll take that. But in math today, we're working on, do you remember what we're working on here?
Unit rate.
We're working on unit rate. So John baked 63 cakes in 7 hours. How many cakes did John bake per hour? What does per hour mean? How many hours is that?
Just 1 hour.
Just 1 hour. Okay, so if you have to mark the text here, what would you do? What's the important information that we need in this scenario? Per hour, 7 hours, 63 cakes. And why did we underline those pieces? Why are they important?
Because we're going to be using them.
Because we're going to be using them. Sometimes numbers are important in a word problem because we need them. So we're going to be using 63 cakes, we're going to be using 7 hours, and we're looking for per hour. So we know that John can bake 63 cakes in 7 hours, but we have to find, what are we finding?
The unit rate.
The unit rate, which is how many cakes in
An hour.
1 hour. Okay, so how would I do that?
Divide 63 and 7.
So show me what that looks like. How do you know to divide?
Because we're looking for per hour.
Per hour, so it's a unit rate, so we're gonna put groups into it, see how many groups of 7 can we get out of 63. So how many times does 7 go into 63? I think I picked the wrong number.
8.
Let's check 8.
That's 56, right?
So did we go 7 into 6 or 7 into 63?
7 into 63.
So your 8, should it be over the 6 or the 63?
63.
Okay, so when I subtracted, I have 7 more left. So since this number is not less than this number, is this number big enough? So what's bigger than 8?
9.
Let's check it over here real quick. What's 7 times 9? I guess you'd have to know 7 times 9. What's 7 times 9?
63.
63. So how many cakes will John bake per hour?
9.
9. So can you write that right there? 9 cakes per hour. Let's make a sentence out of it. Nicely done. Okay, so how about we come over here? And we have another problem. Same type of problem. Is this a unit rate problem? I guess I should put a number here, huh? Okay, so we'll put that number here. So Sarah jogged 14 miles in 4 hours. How many miles will Sarah jog per hour? So what should we do here? Are we looking for a unit rate?
Yes.
How do we know? Because it says, what's the indicator?
Per hour.
Per hour. We're going to underline that. And what other information do we need from this word problem?
The numbers.
Yes, 14 miles and 4 hours. So we're going to do the same thing that we did before?
Yes.
Yes. So jogging 14 miles in 4 hours, how many per hour? So we'll divide what by what?
14 and 4.
14 by 4. So 14 divided by 4. So that number is less. What if you put a decimal after 14 and a 0 and bring down the 0? Will 4 go into that number?
Yes.
How many times?
5.
5. We're going to put that. And we're going to bring that decimal straight up. And what do we know about 3.5? What does that represent?
Miles she jogged in an hour.
Who jogged?
Sarah.
Okay, so how would we answer that? How many miles did Sarah jog per hour? You can just say it out loud. We're running out of time.
Sarah jogged 3.5 miles per hour.
Awesome. Thank you so much. Back to you guys in the studio.
All right, thanks for that, April, and thank you to all of the students out there at Actis Junior High. As a matter of fact, we have all of their names in a drawing because every day what we like to do is take all of the students that have done math problems, put their name in a drawing for an athletic event of their choice, courtesy of our friends at CSUB and the CSUB Athletics Department. So, Audrey, if you would reach in there and pull out one of these names and we'll find out who's going to an athletic event at CSUB.
Lindsay.
Lindsay, there you go, an 8th grade student. I do believe she was the young lady just working on that problem right there. So congratulations to Lindsay. Hope you have fun out there. Any athletic event you'd like to go to out at CSUB, so congratulations on that. Hey, we do have phone tutors available until 5:30. We have our newest ambassador, Audrey. You know what that means? That means you have to tell people about Do the Math. Can you do that for us? All right, you know what? We even have a uniform for you in doing that, all right? All right. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Southern California Gas Company, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.